So now that I've talked a bit about the motivating example, which we're going to look at this from lots of different points of view by the time we're done with this section of the course, I'm going to take a slight detour and talk about factory methods, because the factory methods are used to create the streams in the first place. So we're going to talk about the common factory methods first. And then later we'll talk about the more advanced, or the other factory methods. So factory methods are what are used to create streams. Think of them as the source of the stream. So there's a couple of different ways to create a stream. One way, which we've seen before, is to have a Java collection. So here we might have a list of names, just like our example. We have our words defined as a list, and then we can go ahead and create a sequential stream by just saying words defined.stream, just like we did before. And that's the approach we just used. Or if you want to, you could also use a parallel stream. So you could say .parallel stream, and that will get you a parallel stream. The other thing you could do if you wanted to is you could say .stream, and then later in the stream, you could say .parallel. And that would have the same effect as if we had simply done this. Now, you might ask, why on earth would you ever need to use this approach versus that approach? And the reason for this will become more clear later. But by using the .parallel approach, you can conditionally convert a stream to run in parallel. So if you use the approach that's the .stream or the .parallel stream, the stream will be sequential or parallel. But using this approach, you can actually conditionally decide to make a stream run in parallel or not. And there are various reasons to do this. The most obvious reason for doing this is that you might want to benchmark your program with and without parallel streams in order to see which approach works best based on the input you're trying to process. So the ability to dynamically modify or dynamically add the ability to parallelize or sequentialize, if that's a word, a stream is important in order to be able to get a better sense of how things actually work. Another way of being able to do this is to use an array. So you can see here we have an array, just a good old array of strings. We're going to convert that array of strings into a stream. And once we've got a stream of strings, then we can do something with it. So in this case, we're going to use the for each method using a lambda expression. And in this case, we could use the for each method, which would use a method reference. And I know for my money, I'd rather go with the method reference here. And in fact, I mentioned this before, but modern IDEs like Android Studio and IntelliJ will allow you to automatically convert to and from a lambda representation to the corresponding method reference if it can see how to do that transformation. Actually, it'll sort of always do it. Sometimes it's useful, sometimes it's not. You can, if you don't want to use the arrays.stream factory method, you can use the stream of factory method. So there's a static factory method called of. We've talked about this before. And this can be used to create a stream containing all the elements in an array, and then we could go ahead and print them out with a method reference or a lambda expression. Same basic idea. One of the other points I want you to come away with from these discussions is there's various ways to make a stream, but once you've got something in stream form, then the rest of the processing is typically pretty much the same. So getting it into a stream has some variation, but once it's in stream form, then you can chain together all these aggregate operations to your heart's content. There are even more interesting ways to create streams. This is a really fun one. This is a method called iterate, which is, as you can see, also a method on the stream interface. And so you can use iterate to basically create an infinitely sized stream. What we saw before, things like the of method, things like the arrays.stream method, those would take built-in arrays, which had a fixed size, of course, because you have to have a fixed size for built-in arrays, native arrays. And then they would create a stream. But those streams obviously were bounded by the number of elements that came from the data source that they had transformed or converted into a stream. What's interesting about iterate is it can be used to make unbounded streams, which of course then raises the question, how do we keep the program from running forever? And I'll talk about an example here. So what stream.iterate does is this particular example is going to generate and print the first 100 Fibonacci numbers. So that's what it's going to do. So let's see how it does it. So the first thing it's going to do is it's going to create something called the seed, which is the initial element in the stream. And you can see seed here is something called big integer. So we're going to make an array of big integers, a built-in array of built-in big integers, initialized to 1 and 1. Because if you know anything about the Fibonacci sequence, that's what we need to do to get things started. And so you'll see what happens after that. So we start initializing this thing with 1. Then what we have is a lambda function. And this lambda function will be used to generate the next element in the stream. And this will go on and on and on and on for forever, actually, unless we limit it somehow. So what the lambda function is going to do, the generator function, is it's going to take the big integer array passed to it from the previous phase, the previous stage, and it's going to make a new big integer array, which will take the value of f sub 1. So remember, f is going to be the array. I should probably have called it a. So it's going to be a, or I guess is f for Fibonacci. So Fibonacci 1, which in this case is initialized to 1. And then it goes ahead and it creates a new second element in the array, which is Fibonacci sub 0, which started out as 1, plus Fibonacci sub 1. So you can see that this is going to basically generate the Fibonacci sequence. So this will create the next value. And then that generator will be used again, taking the new input and then applying that to f sub 1 and then f sub 0 plus f sub 1. So this will keep going on and on and on forever. So we're going to end up generating this infinite sequence of big integer arrays with 2 elements. What we're going to do then is we're going to use the map method. And this is really cool. We're going to map f, remember f is a 2-element array, into f sub 0. So we're going to basically transform this stream of 2-element big integer arrays into a stream of single-element big integer values, which will always be f sub 0. But remember, this is a stream which is going to contain the Fibonacci sequence in the 0th location of the array. Well, we don't want this thing to run forever, so we're going to limit it to the first 100 elements. And limit is one of these so-called short-circuiting operations. And so once we've processed the first 100 elements, then the stream is done. And for all the things that we generated, the first 100 elements, we will print them out. So for each element that came through the stream up to the limit, we're going to go ahead and take those values and then print them out. Now, this might not be the, if you were going to sit down and someone said, write me a program that generates the first 100 Fibonacci sequences, first 100 Fibonacci numbers, you might not think to do it this way, right? There's other ways to do it. You could do a loop, you could do recursion, there's lots of stuff you could do. But this is kind of cool because it does it in a very, very concise way. And you'll also notice, by the way, that there are absolutely no control constructs here at all in the traditional Java form of control construct. There's no loops, there's no if statements, there's no switch statements. There's just sort of straight line code with a seed method generating down through the generators. Yes, sir? You could convert this to a parallel stream if you did this. You could say dot parallel here. You don't actually want to do that. I didn't pay him to ask that question, by the way. Basically, you could use dot parallel here, but you don't want to, and that's because iterate used with a parallel stream is very inefficient for a variety of reasons that we'll talk about later in the course when we talk about parallel streams. So yes, you could do it in parallel, but you would find out it would probably actually run incredibly slow. Okay, so that's the end of the common factory method.